Perfect. So a little review. Here for this one, we'll review the technique of substitution. Substitution says if a variable is easy to get by itself, and in the first equation, the y is already by itself, then you can substitute that in for the y in the second equation, and you'll be able to solve. So what that means is in the second equation, in which I had 2x plus 3, but instead of writing y, I now substitute and say, well, from my first equation, the y is equal to 4x minus 4. So I can write that instead of the y, and now I have an equation with just x's. We can combine all of our like terms and work through it and solve. So if I can distribute this 3, that'll give 12x minus 12 equals negative 5. We're having some magic happening today in our notes. And I have some like terms, the 12x, the 2x and the 12x. That would make 14x. I move the 12 over to the other side. By adding 12 to both sides gives me plus 7. And divide by 14, 7 over 14. That gives me that x has to be a half. So the substitution allowed only one variable in an equation, and then you can solve for it. Now we can find y by plugging that x back in. And you could plug it into equation 1 or equation 2. It looks like equation 1 is less work. So I would plug in the 1/2 for my x. And I get 1/2 comma negative 2. On a graph, this would mean that on the graph they intersect at 1/2 comma negative 2. These are two straight lines, and if you graph them using y equals mx plus b, this might have been a little bit frustrating because they would cross not at a nice point. So you'd be a little bit unsure from the graph if you had the right answer. So an algebraic solution is more powerful, I would say, than a graphical solution. Graphical solutions work nicely when the points are nice, but otherwise are sometimes problematic. I'm going to split the page here, and on this side, I'm going to review the technique of elimination. Sometimes you can take one equation and add it to the other equation to make a variable disappear. In this case, what we're going to do is a little bit of setup. So if you want something to eliminate or go away when you add them, the numbers in front of, say, x would have to be the same, but one positive and one negative. So if I added, I get 0. So what I'm going to do is I'm going to take equation 1 and multiply it all by 2, and equation 2 and multiply it all by negative 3. If I multiply entire equation 1 by 2, I would get 6x plus 4y equals 18. And if I multiplied equation 2 by negative 3, I would get negative 6x minus 9y equals negative 33. The elimination technique, you also want to arrange both of your equations so that you have a column that's x's, a column that's y's, and a column that's numbers. Because now when I add this equation and this equation, I'll get 0 there. 4 plus a negative 9, negative 5, and 18 plus negative 33, negative 15. Well, now I can just divide by negative 5, and I can find my y value is 3. To find my x value, I could use equation 1 or equation 2 and plug in. So I'm using equation 1 here. I'm going to plug in 3 for y. Move that 6 over. This one, had I graphed them, would have been really nice. It probably would have been one I could have figured out from my graph because they intersect at a nice point, 1, 3. So this is substitution and elimination with lines. You did that last year in grade 10. We are now going to solve questions with a line and a parabola or two parabolas. It's not anything new. The techniques are exactly the same. And you have a choice. So if we do this one at the bottom of the page, you have a choice if you want to use the substitution or elimination technique. And usually, well, they're actually somewhat the same, okay? But I find that students use the substitution technique a little bit more. You see that the y is already by itself. So that would let me, in equation 2, replace the y with x squared. And if I replace the y with x squared, I have a quadratic equation. That's chapter 3. How did we solve quadratic equations? We have to factor, but before we could factor, we needed to make one side equal to 0. So I can move everything over to one side. And if you wonder which side should you move it over to, personal preference, I find it's much easier to factor if it's an x squared as opposed to a negative x squared. So I always try to move my stuff over so that whatever coefficient I have in front of the x squared is positive. Mental math-wise, I think that makes the factoring easier, that you know, okay, this has to be x and x. To get 2 is going to be 2 and 1. I need a negative 2 and a plus 1. And we get 2 answers for x, which I hope you see makes sense because my x squared graph looks like this. My line x plus 2 would look like that. And now if I have my x value, I could find my y value by plugging back in. What happens when I plug in 2? 2 plus 2. Then for this one, y would be 4. So I would know these solutions go together, 2 comma 4. That's this point right here. When x is negative 1 plus 2 is negative 1, negative 2, no, positive 1, sorry. And so we have the point negative 1 comma 1. That shows up right there on our graph. So the idea is the same, but with 2 lines, when they crossed, you only got one solution. You can see when a line crosses a parabola, you could get 2 solutions. You could, right? It might be some, wow, that's a circle. There might sometimes be, oh my goodness. There we go. There's my axis in the right spot again. It might be that this line is down here and never intersects. Sometimes there's going to be a line that touches it only at one point. And that line that touches a graph only at one point like that is called a tangent line, which is half of your first semester of calculus once you get there. It's just talking about those lines. But in our case, the line went through the graph twice, so we had 2 solutions. And it was kind of important that we put our solutions together, that negative 1 went with 1. You can't ever have negative 1 go with 4, it doesn't work. So those solutions go together. Yeah, here's our examples. This system has no solutions. This one has 1 solution. This one has 2 solutions. And we're ready for example 1. solve this system. And like I said, we're often going to use substitution. Can you see the y is already by itself? So that would let me take equation 1 and substitute it into equation 2. What does that look like? Well, there's equation 2, but instead of writing the y, I'm now going to write the 1/3 x squared minus 3. What kind of equation is this? It's a quadratic equation. What do we do with quadratic equations? We make one side equal to 0. I'm going to rewrite it. I'm going to write the x squared first. And then I have an x. And can you see when I add 3 to both sides, I get 0, so I wouldn't have to write it. Now I'm going to give you two options from this point. And this is as you get into higher level math and have learned more math skills, you get different options in questions. Because you can use one idea in your math skills or another idea in your math skills. And it'll come out to the same answer no matter what. Okay? So this is going to be the two ways I'm going to look at this question. One way, I'm going to factor right away and say this has a common factor of x, and so I would get x times by 1/3 x plus 1 equals 0. Or sometimes in equation solving, people don't like fractions because they're kind of like, oh, it just makes things take longer. Not necessarily harder, but take longer. So if you're not loving that fraction there, you can, in an equation, you can get rid of it. What would I have to multiply to get rid of the 3 on the bottom? And multiply by 3. If I multiplied everything by 3, this would just become x squared, and this would become plus 3x, and 0 multiplied by 3 would still be 0. Okay? Now, I would still have to factor that side. So that took me an extra step before I factored. I take out my common factor of x. But the nice thing about the right-hand side is what makes this 0. X could be 0, and x could be -3. If I split this one up, you get the x equals 0. Can you see this is a little bit more mental math to figure out? And sometimes people actually write out the little equation. 1/3x plus 1 has to equal 0. That means 1/3x would equal -1, which means x equals -3. Get the same answer. The right-hand side, by multiplying by 3, was an extra step at the beginning, but I think solving was easier after that. Left-hand side, we got to factoring right away, but this 1/3 x plus 1 was a little bit harder to figure out that x is -3. But either way, we now have our values of x. But when we're solving a system of equations, we are trying to figure out where does this parabola intersect this line. So we need to find the points where they intersect. We also need to solve for y. Okay? So sometimes people just extend this line and say, okay, when x equals 0, I need to find y. And I would probably go to, of my two equations, try to figure out which one would be easier to figure out. And they both look relatively easy. If you plug in 0 for x, can you see that y would be -3? I can show my work. 0 plus y equals -3, so y equals -3. And now I can write my first solution. I'll write it in purple. That's not purple. When x is 0, y is negative 3. That's my first solution. My second solution, when x equals negative 3, I would have negative 3 plus y equals negative 3. Add 3 to both sides gives me y is 0. My second solution is negative 3, comma, 0. So try your skills at substitution.